Welcome to The Explainer. Today, we're decoding the ingenious architecture of the honeybee hive. We all know they make honey. And yeah, we definitely know they sting. But today, we're going to look way past the basics. We're taking a mind-bending dive into the true structural complexity of these amazing creatures.
So just imagine walking outside and wondering, can a bug with a brain the literal size of a sesame seed actually recognize your face? I know, it sounds straight out of science fiction, but the answer is absolutely yes. Scientists have found that through simple learned patterns and rewards, bees can distinguish human faces surprisingly well. It totally shatters our assumptions about how much brain mass you actually need to be highly perceptive and aware of your surroundings.
Section 1. Anatomy of a Genius, the micro-level marvels. Okay, let's dive into this.
Now, you might think they just have those two big eyes on the sides of their head, right? Well, actually, a honeybee has 5 distinct eyes. They've got 2 large compound eyes plus 3 tiny simple eyes sitting right on top of their head. This incredibly layered array gives them multidimensional sensory input that's specifically designed for detecting variations in light, fine-tuning their navigation, and instantly sensing sudden motion. It's essentially a built-in panoramic sensor suite for their complex daily tasks.
And what those eyes can actually see? It's going to blow your mind. To a bee, a spring garden looks completely different than it does to us. They can actually see ultraviolet light. So to them, flowers are essentially glowing with these UV landing guides that point right to the center of the nectar. It's like an invisible roadmap painted on the petals, completely hidden from our eyes, but brightly lighting the way for our fuzzy pilots to forage as efficiently as possible.
Section 2. Hive Communication and Navigation, the Living GPS.
So how do these highly perceptive insects share what they find with the rest of the hive? Well, they perform a specialized, intricate movement known as the waggle dance. When a forager returns, she doesn't just drop off food, she hits the dance floor to broadcast exactly where she found it. This dance precisely communicates the direction of the flowers, the exact distance, and even the quality of the food. And this brilliantly illustrates their use of a living, breathing GPS system, transmitting coordinates in real time to the rest of the colony.
But hey, to use a GPS, you need a satellite, right? Well, bees use the sun like a compass. And this isn't just based on some memory of where the sun was an hour ago. It's advanced solar tracking. Even if the sky is completely covered in thick clouds, their eyes can detect polarized light patterns in the atmosphere to figure out their exact direction. The sun might be hidden to us, but the bee's compass literally never drops its signal.
Section 3. The Ultimate Efficient Builders, Nature's Math and Hard Work.
5,000. That is the sheer, mind-boggling scale of a single worker bee's daily work ethic. One bee might visit around 5,000 individual flowers in a single day, tirelessly collecting nectar and pollen until she can barely fly.
So, the crucial point is, despite visiting thousands of flowers every single day of her foraging life, one bee produces only about 1/12 of a teaspoon of honey in her entire lifetime. Let that visual whiplash sink in the next time you stir a spoonful of honey into your tea. You are looking at the lifetime achievement of dozens of bees working themselves to the absolute limit. Now, all of that precious, hard-earned honey needs a place to be stored safely, which leads us to a fundamental question of natural architecture. Why hexagons? I mean, out of all the shapes in the universe, why do bees perfectly construct hexagonal honeycombs?
It turns out, bees are expert instinctual mathematicians. The hexagon is mathematically one of the most perfectly efficient shapes in existence. It allows the bees to store the absolute maximum amount of honey while using the least amount of wax to build the walls. Plus, they fit perfectly together without a single gap of wasted space. It's basically a masterpiece of structural engineering happening right in your own backyard.
And inside those perfect geometric vaults goes a food that is essentially immortal. Honey never spoils. Seriously, archaeologists have actually unsealed ancient Egyptian tombs that are thousands of years old and found pots of completely edible honey. How crazy is that? The bees masterfully engineer it so it contains very little water, they make it highly acidic, and they add special enzymes from their own bodies that actively stop bacteria from ever growing. It's a perfect, timeless energy source.
Section 4. The superorganism that feeds us, from democracy to global impact. Let's move to and see how this builds into the incredibly complex social structure of the hive itself.
We need to bust a massive myth right now. For centuries, humans just assumed the queen bee was a dictator, sitting on a throne barking orders at her subjects. But the reality? It's the exact opposite. The queen mainly just lays eggs. It's the worker bees who actually make the colony decisions together, operating almost like a democracy. They collaboratively govern the colony, sensing what the collective needs to survive and acting on it together.
And this democratic workforce doesn't just benefit the hive, it literally sustains the human race. Honeybees pollinate a massive portion of the crops we eat every single day. We're talking apples, almonds, strawberries, cucumbers, the list goes on. Without the tireless collective effort of bees, these vital food sources would become immensely harder to grow, and that would send absolute shockwaves through our entire global food supply.
Now, what's really interesting about this slide is that inside the pitch-black, incredibly crowded hive, they don't just act as individuals bumping into each other. They operate as a superorganism. They communicate through physical vibrations and literally use tiny headbutts to send urgent signals. They work so intimately, flawlessly reacting and adjusting as a group, that scientists describe the entire hive not as thousands of individual insects, but as one single, unified living entity.
Which leaves us with something pretty profound to think about. Look at how they build, how they navigate, and how they essentially vote to survive. How does our human efficiency and cooperation actually compare to the flawless, democratic superorganism of the honeybee? Thanks for joining me on this explainer. I hope you never look at a buzzing garden this same way again.